Elad, we have from Wing, founder, CEO, previously Amazon, creator of CDK. I know a lot of people love that. So it's going to give us a great presentation about consolidating code and infrastructure. So let's see what you got.
Cool. Awesome to be here. It was really cool to see this community kind of forming in the last 6 months, I guess, something like that, even less. I feel like there's room for something like this, of course, and a lot of the uh, a lot of the stuff that we're building is in a way designed around the serverless mindset, I would say. I don't think it's necessarily like one of the things that we're trying to do with Wing is we're trying to say there's no, you know, it's not an either or serverless or something else. I think like the idea behind Wing is to create a model that's unifying the different paradigms into a new paradigm that allows you to think about the cloud in a new way. And so serverless is very aligned with that model in a sense. But we're actually starting to see some interesting traction from like people who use Kubernetes and containers, and so I think like that's the cool thing about Wing in my mind is that it's actually trying to say, hey guys, choose the right tool for your job, right? Like it's not necessarily about your identity. Your identity doesn't have to be you're a Kubernetes shop or a serverless shop. It's we're a long way from that. I feel like the industry is still kind of. So I actually want to most time just like show you some code and play with code. I feel like that's what I do best, and I feel like that's actually gonna do the best job at like explaining what we're trying to do.
I, I, I think you got the right audience for that. So yeah, we love
Awesome.
code. We like getting into the weeds. So that's great. Let's do it.
Okay, so I'm gonna quickly. So I want to start like really with the fundamentals, and then I actually have like prepared like a little demo project, and I'll walk you through some of the code in the demo project to show you some examples. Maybe we can iterate on it and play with it a little bit. But before we start that, let's just do the kind of like the hello world to make sure that we have the same kind of language, I guess. Pun intended. um, and so basically what we're trying to do with Wing is we're trying to say, hey, the cloud is this new type of computer. It's a distributed system with a bunch of services. And when we're building stuff that run on the cloud, especially when we're building applications using serverless paradigms and serverless technologies like Lambda, we're leaning heavily on these services. And so the surface area between my application code and my infrastructure is pretty large. It's not, I have a container and an SQSQ. I have, 20 Lambda functions, and each Lambda function is interacting with like 20 other resources. And so we cross these boundaries a lot between infrastructure and application. And one of the things that we're trying to do is we're saying maybe we don't really need these boundaries. These boundaries exist mostly because we've kind of inherited some of the programming paradigms from the IT center or from the data center world. But if you're thinking about the cloud, when I create applications for the cloud, I actually want to think about the system as a whole and not necessarily think about an infrastructure and my application code completely separate. And I'll talk more a little bit about what I think we should decouple, because I do think that there is some decoupling that needs to happen between what I call application and platform, but that's not the same as decoupling application and infrastructure. And I think like that's one of the nuances of what we're trying to do with Wake. And so what we've done is we said, let's design this programming experience that's tailored for the cloud. And a programming experience is a stack of technologies in a sense. The low level of that stack is the provisioning engine. It's basically the CPU in a sense, so kind of the instruction set. And for that, we actually have a pluggable model. And so you can use Terraform or CDK, and you can actually implement your own backend and we have people, talking about implementing a Pulumi backend and a cross-plane backend. And so you can technically just choose whichever backend you want. And the runtime we're currently supporting is JavaScript Node.js runtime. So that's kind of like the lowest level of that stack. And that we're basically not creating a new one. We're saying, okay, let's use existing tools for provisioning and for runtime. And then on top of that layer, we have what we're calling the standard library or a cloud API, which is very common in programming languages, basically having a library of APIs that allow me to interact with my platform. And what we've been doing with Wing in the past couple of years is slowly designing this layer, because I believe in abstractions. I actually need, and we need like another community, right? I believe in abstractions. I do believe that we've made amazing progress with computing. A lot thanks to being able to identify the right abstractions. I think it's not trivial to identify the right abstractions, but when we are able to identify the right abstractions, we're decoupling concerns. We're able to like give each discipline room to actually work independently. And so what we've been doing with Wing is said, okay, we have this cloud thing, and let's try to identify the building blocks that people use in order to build applications for the cloud. And when you're thinking about this, it's exactly what we've done with traditional software, right? Like we've developed standard libraries, we developed operating systems, and those are abstractions to the platform that we're targeting. And so we've done that in the past 50 years with traditional computing. And I think what we're trying to do with Wing is trying to do this for the cloud. We're trying to create this basically abstract cloud API that allows me to build my applications and focus on the functionality of my application, not necessarily on the implementation of the cloud provider. And then above that, we're building a programming language. And by the way, you can actually use the standard library separately from the programming language. We have support for TypeScript. We actually we're working on support for a declarative model like a YAML, because for some use, just use YAML. YAML is good enough, right? Like if I have a bucket and a queue and an API, maybe I don't need a fully fledged programming language or a framework to define those resources. And so there's a range of ways to interface with this layer, right? But Wing Lang, the programming language that we're designing, the interesting thing about it is this combining infrastructure and application code into a single programming language. Because again, we believe that this is how you're thinking about cloud applications. And so what I'm going to show you is I'm going to show you the Wing Lang experience. We're going to use a standard library. We're going to use the provisioning engines, but eventually the interface that I'm going to show you is going to be this new language that we're building. It's pretty early, still have a lot of issues and bugs, and it's like, it takes time for something like that to mature. And so I created this file called main.w. That's like my entry point. And the first thing I'm going to do is I'm going to use my our import statement called bring, which basically allows me to bring one of the built-in modules. We have a bunch of modules, and you can also bring libraries. And so, for example, I'll show you later. Like we actually have an OpenAI library, so you can like bring OpenAI and then use OpenAI from your application. Now, first thing I'm going to show you is this beginning of this standard library, and we have a bunch of resources there like buckets and endpoints and domain and function and queue and schedule and secret and counter, is another primitive. And when I create these resources, I basically specify my infrastructure piece, or what we call in Wing pre-flight. Now, when I compile this to, let's say, AWS Terraform, so we have like different compilation targets. This is AWS Terraform. going to compile this to Terraform. Let's just make this window a little larger here. And now I can look at my target, and I can see that I have a Terraform file with the buckets. And I can also compile it to other cloud providers. So I can say I can compile it to GCP, and GCP I need to provide some environment variable. I think there's another one that we need. Let's just I can compile it down to GCP, and then I get a different Terraform. Terraform, luckily, can deploy both to GCP and to AWS. If I would compile this to CDK, then I can't compile it to GCP, right? Because CDK only supports AWS, and so the output is going to be a CDK application that I can go and deploy to AWS using CloudFormation. So not all provisioning engines support all cloud provider, right? It's this matrix. Now, the other thing that I can do, thanks to this layering that we have in Wing, is I can compile this to a cloud simulator that we're building. And so the same way we've implemented the GCP, the TF GCP or the AWS or the TF AWS backends for the Wing compiler, we've implemented a local simulator for the Wing compiler that implements these resources using local system primitives. So in the case of a bucket, this would be just a file system, right? And so I can compile this to, actually don't need to specify it, that's the default. I can compile this to sim, and then I get a simulator package. I can also run the simulator package. And so once I run this, we compile it to the simulator, and we open what we're calling the Wing console. And so the Wing console is kind of like this visual map of my application. And currently it just has a bucket. And you can see that I can upload a file to the bucket, for example. I can download, I can interact with my application as it's running in the simulator, because from a developer experience perspective, this is what developers are looking for. They're looking for a way to tinker with their application as they develop it. They write some code and they change it. And so let's start doing stuff. Okay, the second resource I want to show you is a cloud function, and that's a serverless function, right? That's basically one of the primitives that we have in the cloud API. And the cloud function is an interesting primitive because it's also a compute resource, right? As opposed to a bucket, which is just an API, a service. Here, I actually have some code that I want to be able to run in this function. And the way we are expressing this API in Winglang is using what we're calling in-flight closures. And so in-flight closures is kind of like a code. It's basically a code closure, right? It looks like a normal code closure, only that it has this modifier called in-flight. And one way to think about it is kind of like this async modifier, but it's not only async in time, which is what async does. It's basically delays the execution of this thing. It's also async in space in a way. And so this block, this code that I write here is basically going to be packaged into the way this is implemented, right? It's going to be packaged into an archive, uploaded to S3, and executed on Lambda, right? When I deploy to AWS. And so it's basically, Wing has this capability to package these code blocks and ship them to the cloud and then run them when the system deploys. And when I'm in my simulator, I can just run them here, right? I can easily just run the function here, and I can see my logs, and it's basically just like immediate. And I can also debug, and basically it's running locally on my machine. It's very simple. Now, when is this becoming really interesting? When I'm interacting across these layers, right? As I mentioned earlier, when you're building applications, especially applications that are serverless in nature, you have a lot of interaction between your application code and your infrastructure resources. And so, for example, let's put an object in my bucket. And you'll see that as soon as I've done that, my visual representation shows me that there's a relationship between my Lambda function and my bucket. And it also knows what the nature of that relationship is. In this case, it's basically putting a file on the bucket. If I do list here, for example, then we'll see that now I have another operation that's happening on this. And this is obviously useful when you're compiling to targets like AWS, because this is how we're generating IAM policies for the Lambda function. And so just showing you this real quick, if I compile this to AWS, I can basically see that my IAM policy has lists and puts and a bunch of other things that are needed to perform these two operations on S3 buckets. And so, and this is a recursive model. So if my code uses some other code that uses some other code that needs some permission, that eventually it'll render the full IAM policy required in order to be able to actually achieve this thing. And so this is definitely one of the things that people like about Wig is like you really don't need to deal with IAM policies, and they're always going to be list privileged based on the actual code that you're writing. And of course, I think this window is constantly, you can't see it, right? Like it's like just on my computer.
You just sound crazy. It's like, what is this? But we don't see
What
it.
is this thing? Okay, so let's just check that this is working. Cool, I have my bucket, great, right? And so on and so forth. And so now let's jump to like a bigger application. I'm going to show you something that's a bit more interesting and a few more ideas around Wing. But just maybe if there are any questions at this stage or thoughts.
So you've mentioned GCP and AWS. Are those the two cloud providers that you generate to, or do you have?
So first of all, it's a fully extensible model, and you can create your own platforms, or what we call platform provider. It's basically like a library that implements the standard library and decides everything about the output. So you can decide which provisioning engine to use, which cloud provider to use, whatever you want. We have a bunch of like built-in providers within, that we ship with Wing, like the simulator, AWS, TF Azure, TF GCP, which is like, Terraform compatible now, you should say, right? Like it's open tofu or Terraform. And then we also have AWS CDK, but as I said, and it's not full, right? Like you see, there's a lot of missing pieces here, and it's an open source project. We see people starting to like fill in the gaps. But as I said, it's like an open model. And so if you look here, basically there's a way to create custom platform providers in Wing, and there's a programming model that allows you to basically decide everything about how your application is deployed, and then you can also deploy custom platform providers. So for example, we have some requests to create crossplane, like I mentioned, or Cloudflare target. So it's a pretty powerful tool, technique.
It seems like out of the box, you have the big three and Terraform, which is cloud agnostic, basically. So you can do all three with that. So
yeah, exactly. And Pulumi is definitely on the roadmap. Just looking for opportunities to work on that. Okay.
Just one question for you, actually. Your function code there. Can you just go back to your example function code you had there?
Yeah.
So, are you doing any manipulation on this, or what you put inside of that in-flight block is exactly what goes in AWS, for example, into the Lambda function? Like, is there any kind of translation done? Like, is this just
This is not JavaScript. This is Wing.
Okay.
It compiles to JavaScript.
Okay.
And we actually have we actually also have support for like just calling in a TypeScript handler, right? So if you already have a TypeScript handler, you can basically just say, okay, I'm going to use Wing to define my infrastructure. And I think we're just working on this. There's a special way to basically import a TypeScript handler and just use it without having to like write your application code using Wing. We've obviously received there are obviously people who have existing systems and they want to be able to use Wing. But this is Wing. This is Wing code.
Okay, so this is an intermediary format that then you can convert to all the other formats out there to put in, for example, a Google Cloud function, I think they're called, or a Lambda function, and then and it only outputs, I think what you said, TypeScript right now is what the function will be, the runtime of the
JavaScript. No JS, Java.
Yeah, okay,
You can see
great.
it here. I can show you.
Oh,
This
you
is
have the output of what it actually created. Okay.
Yep, exactly.
Yeah, okay.
And then you can see like the bundles, right? See, this is the archive.zip that includes all the dependencies. And so if you use any dependency, it'll take care of just do whatever it takes to get me to the cloud.
Okay, great. Thanks.
Okay, so now I'm going to open.
I had one more quick question. So how scoped down is the policy that it generates? Is it scoped down to the hello.txt key, or was it wider than that?
Currently not. It's wider.
Okay.
So it's not it's a good call out. Yeah, I mean, like it's not scoped down to at the key level if you're talking about buckets, but it's scoped down to the method, to the operation level. So if you're doing a put, it'll go with put objects and start, right? You could customize it though. Like you could at the platform level. One of the key ideas behind Wing is that the cloud API that we're exposing, we're trying to design it so it will be valuable for application developers, for the application, in the sense that it's focused on the functionality of the resource. And at the platform level, you're actually coding below the abstraction. And so at the platform level, you can customize it to your liking. So you can basically say, I want this Lambda function to have like a more explicit IAM policy, because now you're actually know that this is going to go to AWS and it's going to be deployed, on Lambda. And so this ability to code against a functional interface and then customize below the abstraction, I think it's key, right? Because I don't think that it makes sense to actually, I don't think it's realistic to create an abstraction that holds every capability that every cloud provider offers, right? Like that's actually almost the opposite of an abstraction. And so what we're trying to do is we're trying to decouple, that's what I mentioned earlier, decouple the application and the platform. Like put a line that says, this is the part, this is the business logic from a cloud perspective. So it does include cloud resources like queues and buckets and APIs and websites and functional units of my system that are represented through cloud infrastructure. But then there's a platform piece, which is usually the responsibility of a different team in many cases. And I think that what we're seeing in serverless is really interesting in that sense, because on one hand, the serverless kind of movement is encouraging a lot of people to take ownership on cloud infrastructure. On the other hand, we're talking to a lot of people that are saying that developers, the application developers, are struggling with that, because the cognitive load and the amount of knowledge you really need in order to create good applications that run on AWS or GCP or Azure is too big, and you want the developer to actually focus on the problem domain of the business and not necessarily the problem domain of the cloud. And so I think what we're trying to do is we're trying to put the line in a different place so that developers are able to own their application end to end, so they understand exactly how the application works from a distributed systems perspective, but not necessarily owned it up top to bottom. Because I do think that eventually, if you go to the industry, you see that in most companies and most enterprises, and like there is a team that's dedicated to the platform side, the VPCs and the IAM roles and the networking. So that's what we're trying to do. And this is one of the biggest challenges in this project, is kind of like telling this story, right? Like it's a bit of a nuanced story, but I feel like it's actually the key to solving a lot of the pain points that we're seeing with cloud development. I don't know if it resonates. I know that I'm in if I go to talk to Kubernetes people, they're like, developers don't even want to know that the cloud exists. If you go to serverless people, they say developers should understand everything about how VPCs work. And what we're trying to do is we're trying to actually find some better model, right? So
I like the middle ground, but I still think the since it's there, and it's generated from your code, I think the responsibility will still mostly fall on the developer, right, writing the code. And to David's question, right, it's the starting point. I'd rather start it with the more least privileged policies, right? He was asking about the security part, rather than the loosely, right? Because he said star, right? It's probably allowing put object to all buckets in that account. Is that sort of
No,
how
no,
it?
no, no, not all buckets. It's
Okay,
particular,
just that one bucket. Okay.
not the particular key. You know, like
Yeah.
some people are more particular than that, which I super respect. But
Yeah.
that's something that's currently our model is not designed to. It's not that we
Yeah.
can't, right? Like because we do see the code and we can, but we decided to basically say, okay, it's at the operation level, not at the specific call level, right?
Cool.
Okay, so this example, what I wanted to show you here is just this cute little system that does translations. Okay, so you basically handed a document, and it goes to GPT-4 4.0 and asks it to translate it to a certain language, and then it stores the result in some bucket. And I want to show you this system. And so we'll start with like a translator. And so this is basically a class. Wing has classes like any programming language, object-oriented programming language. But one of the interesting things about Wing classes, as opposed to traditional programming languages, is that every class in Wing, every object in Wing, has both a pre-flight API and an in-flight API. So it can include both application code and infrastructure. And we can bundle them together into units that can be reused and instantiated into the application. And so this class is called translator, and it has you give it the source language and the target language, and you give it a pointer to the OpenAI API. And internally, it creates a bucket. It has a bucket and a queue. And every time someone is posting a message into the queue, it calls, basically the way it works is like you call translate. So here's like the method called translate. You provide the name of the file and the data, and then it just pushes it to the queue. And then the queue it's picked up from the queue, goes to OpenAI, asks for the translation, and stores it into the bucket. Okay, pretty straightforward. And I'll show you what this is again. And so I have like this test here. And so in this test, I basically define my OpenAI secrets, and I create a translation from English to Spanish, and I have a bunch of fixtures here. And one of the things that we found really useful is that you can create like these little cloud functions as tools. And so in this case, like I have this cloud function that goes over all the fixtures and just translates them. So I can like see it see that it's working. I can play with it. And then there's also a unit test here. You see Wing has like this built-in support for unit testing. And think about it, it's unit testing for complete cloud systems. It's not just unit testing for your application code. And what it does is basically calls translate. And this library, this OpenAI library that we have, which is kind of like a third-party library, it's not part of the standard library. It has a mode of operation when it's running in a test where it's just returning some mock data. And so what I'm doing here is basically sending a request and checking that the mock data that was right, because during the test, I don't want to go to OpenAI and like, because think about tests are running in CI. And so now let's run the Wing simulator, see how it looks. So this is, starting to become a little bit more interesting. And so we can see the translator here. We can see the queue and the bucket. We can see the key in the model here. And then we can see like our little function that allows me to translate all the fixtures. And we can like go and, sorry, struggling here. And so we're going to start translating on it. And then basically just, you see the queue is picking this up. And we see like a bunch of results, and we can go to the bucket, and we can see that Spanish, I don't know how to read this, but I trust OpenAI, I guess, at this point. Not really.
It looks legit.
I tried it with Hebrew to make sure that it does do something. It doesn't tell me, I don't know who you are. I'm an I'm an LLM model or something. And so we have this building block now, which is basically a translate. Now let's let's go higher. So what I have here is I have like a big program, and let's see what this big program does. And so in this case, I basically have I want multiple translates. So basically I want to publish a document, and I want the document to be translated to like multiple languages, let's say. Okay. And so I have like this array of languages. So I have French and Hebrew. Great. And then source language is English. And then I have like my input bucket. So I want everything that you just drop into that bucket to start getting translated. And you know what? Let me open this view. It's going to be pretty big, as you can see. But we actually have like a nice tree here, and we're working on, now that people are starting to build bigger things with Wing, we're working on like improvements to the visualization, and it's useful when you're able to like, actually just like walk around. But we want to do this. There's some really cool plans on how to do it. But let's see what the architecture of this solution is. So basically, we have like a front-end website that talks to an API. The API has a bunch of routes. So it has like get, post, get languages, get docs, post docs, and get docs key. So it's basically allowing me to, and the website is calling this stuff. And then I have a logical unit called translators. And so I have like all my translators in this class. I have like English to French and English to Hebrew, and each one of them is like this block that I tested earlier, right? Like, so I know that this one's working and it's supposed to do what it does. And you see that each one has like its output bucket. So I can, and what else do I have here? So this is the input bucket. I can see that I have like an event handler here. So every time something is uploaded to the bucket, it'll trigger the thing. And then I got another unit called tools, which is like these Lambda functions that I can use to play with my system. So I can like say, translate this, redrive everything, reset, goes to the bucket and cleans it up. And so this is the system. So let's see if it's working for a second. So first of all, I'm going to go to the website, and you see that it's empty. And then let's just use this. I was thinking, what can I do? I thought maybe I'll use ChatGPT to create something interesting. Write a poem about serverless. Awesome. Copy. I'm going to go here. I'm just going to paste that here. And you see that it's basically translating, la, 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 and finished. And so now if I go to my website, I see that now I have English, French, and Hebrew. And I can see that this is the English version, and this is the French version, and this is the Hebrew version, which I can say it's actually amazing. And I can also add languages, and so we can add Klingon. And so as soon as I add this language, we actually have some bug with the reloading invalidation stuff. So it's taking a little long. But now we see we have 3 translators, right? So we have like Klingon, we have French, and we have Hebrew. And we shouldn't have like the Klingon translations yet because it's all because we need to redrive it, right? We basically need to like run so I can go and I can redrive this thing. Let's see, where is it? Redrive, boom. So now it's gonna start translating everything again to make sure that all the buckets are ready. Translate to da 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 da. And we got the Klingon translation now. With some disclaimer.
Yeah.
Okay, so let's see the code a little bit, because so you understand the system. I want to show you what it's like to build this in Wing. And it took me 2 hours to build this, like literally 2 hours. It also works. I've deployed it to AWS using Terraform and using CDK. Both of them work, which is, to me, every time this actually works on the cloud, I'm like, oh my God, this is amazing. And so I can show you that as well if you want. And so let's see the code. It's supposed to be pretty straightforward to understand. So we have like the input bucket here, and then we have a class that manages the translators. And so remember, we have like this languages array. And so what we do here is we do a for loop for each language, create a translator, and think about it. Translator is like whole infrastructure, right? Like there's like queue and a bucket, and it keeps like 2 maps of translators and readers so that I can actually interact with these translators from later. And then also have like an in-flight API called translate all, which gets like the data and then iterates on all the translators and calls the basically translates. And there's another API called read, which basically finds the translator, what we call the reader function. There's some nuance here, but it's not that important. Finds the readers based on the language and then returns the value. And so now I'm instantiating the translators, all the translators. And here actually, this really sweet. Okay, let's skip this for a second, and I'll show you. I'll talk about it in a sec. And so here is this input bucket. I'm adding an event notification that says every time something is created on the bucket, read the content from the bucket, and then send it to all the translators. So that's basically the logic of the. And then we have like an API, and so we create like a cloud API here. And what do we have here? Result. What is the result? Why is it called result? Oh, result is it's basically the list of languages. It's like so yeah, when you do get languages, it just returns all the languages. The reason this code exists is because I'm concatenating the source language. So not interesting anyway. Get docs. So this is basically going to the input bucket. It lists all the objects, returns this list. And then we have docs key, which goes and basically reads the specific document from the translator manager thing. And this is basically posting. So I can actually post using the API. I can go and we haven't used that that route, but when I'm posting, I just get a body, right? And I need to find the name of create a name for the objects on the bucket. And I was like, oh yeah, maybe I'll take the contents, maybe I use some hash, maybe I'll take the contents and like lowercase it and do something about it. And then I was like, okay, let's see how this namer works. So what it does, it goes to ChatGPT and it says, okay, make me a file name. And so here's the prompt: make file name, contact, all lowercase, word delimiter, extension. Just made up this API, right? Like it's added some stuff to it, and then just call ChatGPT. And I literally, it works amazingly. I actually have like this, I can run this separately. So I have like this other application so this is just the test for the namer. And let's see. So yeah, see this is the names that it creates. This is the result. And it was kind of mind-blowing to me, right? Like it's kind of like, okay, so now I'm just writing like little utility functions using GPT. It's interesting. I feel like it's an interesting kind of, suddenly that we have this amazing tool. I can just define the API. I don't have to actually implement it. I can say, okay, this is the and so this is the namer, right? So it basically takes the body, goes to the namer, asks it to give it a file name, and then puts the file name into the bucket. And I was actually thinking that maybe we need I need another prompt to verify that the output of the namer is actually a file name, right? Because if it would give me something that's not a file name, then I need to ask him to try again or something. And then we have a bunch of back office tools. And so we have this function that performs a translation, and we have the redrive. So redrive basically goes over all the keys and then says translate all for each key. And then we have reset. And here we have the front end. And so the front end is basically using a cloud website with stupid HTML. I'm still at this stage where I'm writing HTML like this. But the cool thing, the interesting thing about here is that we have this capability called add JSON to cloud website, which allows you to add deploy time information to the static website. This is deployed through CloudFront when it goes to AWS. And so what we're doing here is we're creating this file called config.json, which basically points to the URL of the backend. And if you saw here, my backend is enabled with course. And so what my front end is doing is just, fetching /config. It now has the base URL, goes to /docs, reads the docs, reads the languages, renders the table, right, with all the links. And that's it, right? Like that's basically the front end. That's it. And then I'm basically instantiating all these resources here. And we have this big complex system. Again, it was really fast to build and really fun, like because you iterate and play and change things and move things around and connect. You can see that we have some UI hints we have some UI capabilities. So for example, we can decide maybe to hide a bunch of nodes if we feel like, we don't want to see them. We also have this thing called here, we have like this UI library, which allows you to add UI to the console. So if you look at these, see that I have like source language and target language here. And so this is basically hints to the console that are embedded into the application that allows me to actually create like nice UIs, and we're improving that, and you can create buttons that go and run code on the cloud. And so this is a pretty powerful piece. That's it, I guess.
There's so much. Still processing.
That's it. That's just it.
It's one of those things where I feel you have to kind of dig in, because I mean it's a lot that you're doing, right? Even the simple function to create a text file name, right, or a file name with GPT. So it's pretty interesting. Something that I'm very curious with is the tests, right? So I'm assuming it's all running locally, right? It's not like you're actually deploying something to the cloud. So how are you mimicking those resources, and how hard is it for Wing to actually keep up to date with all the new stuff that's coming out for each of the providers?
Yeah, so it's basically part of the reason we're creating an abstraction. So instead of actually saying, we're giving you access to everything on the cloud provider, and then we have to go chase the cloud provider and implement the nuances of those services. And local stack is doing this, and it's an amazing project, but it's like it's a lot of work, and the fidelity is not promised, right? Like I think like the problem with this is that the more complex these implementations are, the less, the more possible, degrees of freedom for them not to actually do what you're expecting them to do. And so we've taken a very different approach in that sense, because what we're saying is we're designing this API as the functional contract between the application and the platform. The functional contract, right? Like it's basically saying a queue is something that you put in messages from one end and you get in messages from the other end. And if you'll see the APIs we have, like they're slowly, growing, but you really try to keep them on the functional side. So if I actually look at Cloud Function, then I have environment variables, memory, timeout, and concurrency, right? So I can specify the concurrency level of my function, and that's it. That's basically the current API we have. I'm sure it's going to grow a little bit, but that's actually easy to simulate, right? Like that doesn't require me to go and chase AWS, because I'm basically implementing a contract, and as long as this contract is compliant with with that behavior, then I can actually write functional tests that test my entire system. It's not that we're saying you don't need to test on the cloud. It's just that we're saying you can actually move a lot of the quality left, right? Like you can actually discover a lot of logical problems and a lot of application level problems before you even deploy one resource to the cloud. And then our testing system actually allows you to test on the cloud. You can run the same test after you deploy to AWS. So you can like reuse the same test that's running in the simulator. You can reuse it and run it on AWS or GCP. So that's the approach, right? Like it's basically kind of trying to think about it a little differently.
And is the idea this is generating, like you showed, the Terraform and all that, and for you to take that and then use your own CI/CD pipelines to get it through, or do you offer some sort of, I saw some sort of, it's going to be hosting because you're going to another provider, but some sort of deployment mechanisms that you manage?
So currently, the open source project ends with these artifacts, and you can go. I can show you. You can basically go and you say Terraform. Let's see what's if I do this. Terraform apply. Sorry, you need to compile first. TF-AWS. That's actually taking a long time recently. So you compile the Terraform and you just apply, or you just do CDK deploy. The CDK integration here is actually through the CDK JSON file, just calls Wing compile with the CDK platform. And so when you run CDK, if you're familiar, just do CDK deploy, CDK sync, all lookups work. It's standard CDK stuff. And so yeah, I can just go and apply this. I think like I added another language, so it should show me some difference. And so yeah, from the open source perspective, this is what this is the boundary. But we are working on not necessarily deploying, but exposing the rest of the life cycle through a service. So you can actually like see the process of the application being rolled out. You can connect to your production application using the same console. So you've seen this console. So think about being able to actually use this console in production and interact with your application the same way you've interacted it from when you developed it, and see the same logical units and the same abstractions. And so that's the commercial side basically of what we're working on.
Cool. Is that you use a little icon to open? There's a Wing extension for VS Code, I'm assuming.
Yes, it's a language
Okay.
server, and yeah. Definitely.
Okay, cool. And I had one other question, but I'm blanking out. Oh yeah, the resources, right? So you showed bucket, function, API. What are our queue? I'm assuming you have like events or okay, there you go, all of them.
So yeah, APIs, API gateway. By the way, we actually have customers who are implementing API with load balancer and a container. Fair enough, maybe they have cold start issue. They want to buckets are object stores. Counter is actually one of the interesting resources. A counter is like an integer that you can increment and decrement, but it's atomic and it's distributed. And so when this is deployed to AWS, you can actually like see that it's creating a Dynamo table with an atomic counter. So I think like that one's actually cool because I feel like counters are useful for distributed systems, and most of the cloud providers don't really offer like a primitive called counter, but in Wing it's pretty straightforward and easy to do that. And the simulator implementation is very straightforward. Domain endpoint is actually an interesting one. It's a resource that tells Wing that something is an endpoint. So basically, an API has a endpoint in it. A website has an endpoint in it. Containers, public containers can have an endpoint in them. And one of the things that we have, for example, in the Wing console, you can see these endpoints here. So basically, we can like surface all the endpoints that are the outputs of the application. And if security allows it, you can open a tunnel into into the local endpoint, which is super useful for like building webhooks, based applications, and interfacing with services that are already on the cloud and being able to like iterate really quickly with your local machine. So these are endpoints. What else do we have here? Yeah, function is the serverless function. On deploy is basically you can specify an in-flight closure that runs during deployment. So it's kind of like a custom resource in a way. And we have queue, we have a schedule, secrets, service is a long-running service, a containerized service, or something that's not a one-off serverless thing. Topics are pub sub, and website is the CDN-based static website. So those are the ones that we have in the cloud API. But we have this repo called winglibs, which is basically kind of like an open ecosystem. Anybody can publish stuff through this repo, and it's growing, slowly growing. So we have like Bedrock, budgets, and those could be like very specific resources. Like, for example, we have SNS, and so when you bring SNS, it means you're going to be on AWS, right? It's not an abstract thing. It's concrete. You can use, I think, like there's an EventBridge one as well. Yeah, there's a DynamoDB one. And so we're not trying to say you need everything to be abstract, right? We're trying to say one of the interesting things with this programming model is that it allows you to actually implement the simulated version and the cloud version. And so for DynamoDB, we spin up DynamoDB local, and for SNS, we just, I think mimic the behavior. Like you can make a decision, pragmatic decision based on like your needs, and so this is cool. Like we have.
And what's the process to get one of these libs in, right? So
super easy, super easy.
Yeah.
You can just like, you clone the repo, you call makelib, it'll create like a little scaffolding. And basically, Wing library, one of the cool things about designing a language to actually like solve some problems. So basically a library in Wing is just a directory with a Wing file. And so you can like just create a Wing file with a bunch of public types, and we take care of the publishing, which I think is one of the things that I've seen with the CDK, which has it's a barrier for people to be able to actually like share. And so once this is committed and merged, we take care of publishing it to NPM. So we actually have like workflows here that make sure that versioning works, and it also gives us a really good way to like test what we're doing with Wing in a centralized place. So every time we break something, we're able to know really quickly and fix all the downstream libraries. It's kind of like this interesting approach to ecosystem.
There is a question in the chat by Ziad. Is there an escape hatch that lets you configure read and write capacity on the DynamoDB table?
Excuse me, again?
Yeah, is there an escape hatch that lets you configure read and write capacity on the DynamoDB table? I'm assuming that's in the context of the counter, Ziad?
Yes, sorry, I was on mute. Yeah, exactly.
So you can technically use CDK escape hatches, because eventually Wing uses AWS CDK or CDK for Terraform or CDK for Kubernetes. We actually have like CDK for Kubernetes support here somewhere, yeah. And so you can use those escape hatches, and they basically just like patch up the YAML, right? So you can do whatever you want. We have a item in the roadmap to kind of give you maybe a better way to traverse the tree and like find the nodes that you need to patch, because that's usually a problem. Like you need to like copy some quirky logical ID, and so one of the ideas is like you'd be able to say, I want to give me from this node, I want to find the Terraform resource called AWS DynamoDB table, and then patch that. So just making it a little easier to query the tree is something that I feel can make it easier. But otherwise, you can just use CDK escape patches.
Okay, thank you.
Hey, Elad, so I tried Wing pretty early. I think it was late 22, early 23 in that time frame. And one of the questions that I have is about the progress on something. So what I recall is there was this layer of abstraction. So I did a bunch of stuff and then I was trying to debug it and I was trying to figure out why it wasn't working in the cloud and things like that. And I'd found that the bucket names were really weird and weren't really human readable and things like that. So I think you guys went ahead and made the bucket names and all the resources that you're creating much more human readable. But kind of the question that I had, where you have this layer of abstraction where I don't necessarily know what's going on. Like, for example, I created an SQS queue, and then a month later, I was trying to figure out why I was doing all these SQS reads, and I figured out that, oh, Wing is still running this polling on my SQS queue. Right? And one of the things that I kind of posed as a challenge was, well, I can get it to work, but can I actually operate it at this level of abstraction? Like, I can get this working, but if I'm trying to run this in production, can I monitor it? Can I debug it? Can I see what's going on? Have you made any progress in that area?
Not progress that we can share yet,
Okay.
but it's definitely top of mind.
Okay.
I absolutely agree with you. Like, I think like the more you're using abstractions on the left side, you need those abstractions to carry over to the right side, right? Like you need to make sure that you're able to restore the same mental model when you're operating the system. And I think that that's actually a really interesting space for us and something that we can do that really kind of changes solves some of the friction that people have with CDK today, for example, where it's the same problem, right? Like if you're using CDK abstractions, the higher you go, the further you get from the actual runtime layout, the runtime implementation, and then you go to the AWS console and you see like 30 Lambda functions, and you don't have any idea what these Lambda functions, where do they even belong? And so just it's basically the idea is to take this Wing console and allow you to connect to a production system. That's how we're thinking. And so if you have a queue, you'll see the queue in the context of the application, and you're going to be able to like jump over to your SQS console, right? Like you can open the hood if you want and jump into the concrete implementation, but you'd be able to like manage your application from a logical point of view. Does that make sense?
Yeah, that does make sense. And I think that the deep linking type feature of being able to dive into what's going on behind the scenes is very nice. I also liked your kind of built-in UI type functionality. I'm working in a similar space to that, so I saw that and I had some delight. So thanks for building that.
Thank you. Yeah, definitely fun. I'm excited that we've reached a point where we need to like start figuring out solutions for like bigger systems, more complex systems, navigation, search. That's really exciting.
Cool. Great stuff. Great stuff. Thanks for joining us, Elad. I definitely need to take this for a spin and play around with it. I know David mentioned he already did a few years ago, so we'll see. We'll kick the tires and the best thing about this is getting feedback, right? So see how
Yeah, exactly.
this can be improved.
Please, join our Discord. We're there. Hang out. Tell us what you think. Yell at us. Really, really love any feedback.
Cool.
Thank you very much.
We'll wrap it up. Tomorrow, don't miss. I'll be on a live stream with Michael Yendo doing part 2 of the AppSync, kicking the tires in AppSync and just trying it out. So We're building a pizza API for the Teenage Mutant Ninja Turtle. So,
Oh, cool.
so join us tomorrow and we'll have some fun. So thanks again, Elad. We'll
Thank you guys
talk
for
to
having me.
everybody later.
Bye.